to today's threat landscape. We're going to look at two sample attacks against machines we've set up on a demonstration network. These two machines are going to be XP computers, one which is largely service pack up to date and one which isn't. In this particular example, we've got a little network set up, and on this demonstration network these machines are DHCP allocated IP addresses, and our attacker PC is going to represent a machine coming onto the network, being plugged into the network via a cable and getting an address. First thing we would need to look at, being an attacking PC, is to identify machines on the network. So that's what we're going to do now. Using a program called ZenMap, a port scanner, we're actually going to scan the network using the range we've been allocated via DHCP, looking for some machines on the network. So under there we're going to put a little range under there, we're going to kick off a port scan and see what we actually identify. The scan is started and running on the machine. Looking back, we'll see what results we actually get back. Under there we've found two machines, one which has quite a lot of information about it and one which is highlighted which does not. Interesting enough, the one which is highlighted is one which is running a client firewall. The one now being shown actually has some ports open we're going to look to attack and exploit. These are ports 445, and other information being displayed around there is the operating system name and the expected service pack level being detailed under there. In essence, it shows the service pack level on the machine is quite low. We can see that port 445 is open. We're actually going to try and run a vulnerability MS08-067, which is the well-known and well-publicized configure vulnerability. With this particular vulnerability, we're going to exploit it manually rather than using some malware code that configure did. And we're going to try and inject VNC into RAM on that target machine. Now, the VNC isn't installed on the target XP machine. We're simply injecting the code to run VNC into RAM against that target machine, which has this vulnerability associated with it. So we're overloading the Windows File and Print Server service, injecting this code in there, and it's going to initiate. And there we go, it's actually initiated for us, giving us a remote control session to that particular target machine. Now under there we've got the VNC session running. We can see some documents under there, we can see a restructured document. We've got that sort of complete remote control over that particular machine. We can do just about anything we want to under there, just using this Windows vulnerability. It's important to note that Configure was very successful, and one of the reasons why it was so successful is because antivirus wasn't really able to stop it. And the reason being is, once again, it used this vulnerability and injected code into RAM on target machines. Antivirus is very good at scanning files on hard disks, typically read and on write, but not very good at scanning items in memory. So in this particular case, we've demonstrated this problem by executing VNC code into RAM on this target machine. In the case of Configure, antivirus was able to pick it up, but only at the stage in which it dropped a file to start up next time round. So that's exploiting a Windows vulnerability and showing what can actually be achieved with that. But most of us these days have Windows patched largely up to date. But what about some of the other applications we may well be using? For example, what about Adobe Reader? Have we all got that patched up to date? Not many organizations can say that. So in this particular case, we're going to run an Adobe vulnerability, the Adobe Cool Type Sing vulnerability, which affects versions 9.3.4 or before of Adobe Reader. So under there's our vulnerability we're looking to exploit, and we're also using the shell, the reverse shell from part of this software package to give us a shell control over that particular machine, allowing us to launch a number of different attacks against it. In this particular vulnerability, we're actually setting up this attack PC as a web server, and the target machine we're going to have to actually get to browse to this particular web server that's been set up, as I'm highlighting there now. So on the target machine, we're actually going to launch the websites. Typically we might achieve this in an organization by dropping an email to all at the organization's domain name, or sales, or finance, or just pick individual names. But in this case we've just clicked a shortcut link to demonstrate the purpose. There is the web server address, and we can see it's sending the payload through. Under there we can see the PDF file attempting to be opened. It's a crafted PDF that's being launched against it. Under here we're just waiting for the process to go through. It's sending over the packet details. Under there it's trying to create the reverse shell. As we see it go through, it's also going to try and migrate the process from Internet Explorer to Notepad to automatically hide that process away on the client machine, allowing us to close Internet Explorer on the target machine as if, and sort of resume operation as if nothing was going on with it. So there we are, the machine's returned to normal. It's functioning in a normal kind of way, and to all intents and purposes it looks okay. We can actually look under there at the control panel into the file settings, and we'll actually notice that the client file on the machine is actually running. But it isn't actually very effective against this particular vulnerability because the XP client firewall is one direction, and we have actually initiated the connection from the XP machine itself. So it's an outbound rule, and those are allowed by default within the XP client firewall. Processes show the Notepad process, which is what we migrated it to, running. And a user could possibly identify something going on by doing a net stat and looking at the reverse connection. Most users would be able to do that. So what we'll do now is flick back to the attacker PC, and we'll attempt to bring the session to the foreground. We can have many sessions. We're just going to bring this session we've got running with the XP machine to the foreground, allowing us to run a number of different vulnerabilities, or different payloads I should say, against that particular machine. So what we'll do now is actually execute, well, let's have a bit of fun. Let's execute Solitaire on the remote machine, just to show what kind of control we've got over that particular machine. So if tagging through, we see that Solitaire has come up in the background there. If we want to be really annoying, we can do it multiple times, just to sort of prove the point. We've got that remote control. Over there we can launch code against that machine, any code sort of residing the machine. We can also dump code through to it as well. So what else can we do with the system? Well, we can look at the IP configuration that's running under there. We could attempt to modify the IP configuration. We can do some route forwarding. We can modify the static routes on the system. We've got those sort of options there. These are some of the commands available. So just highlighting some of those to you. But what we'll do now is we'll attempt to perform a key scan. And with this key scan, we're going to record information being typed into Notepad on the client machine. They've been recording the keystrokes, just like a piece of malware might do. We're doing it manually. So under there, we'll just say, how are you? Typing into Notepad, and we'll see if we can record that information back here. And we can, there we go, it's displayed under there. So we're capturing personally identifiable information. Very easy to do with this piece of software. So what else can we do? Well, a whole raft of different things. We could look to run a screenshot perhaps of the system. I've already mentioned the port forwarding rules we could trigger under there. We could do some downloading of files. We could list local files. Let's list some local files on the system. There we go, the short story that's been displayed under there. So what we'll try and do is download that file to the local machine to have a look at it. There we go, the file downloads. And now if we access the root folder, which is the default folder for downloading files into, we should be able to see that file there. Scroll it down. There we go. There is the text file shown under there. We could actually modify and re-upload it if we wanted to. Okay, I mentioned that we could do a screenshot, and here we go. Dumping a screenshot from the actual machine, so there we go. We can get that information back as well. We've got, this is really to reiterate how much control we've got over that target PC. We could actually go further in this particular case. We look under this. This machine is actually a laptop. We'll do a look at the webcams we've got running on that particular machine. So there we go. We can see when we've got a webcam running under there. So we're going to actually attempt to connect to it and take control of that webcam and take a snapshot. See if you can see me. Well, in this particular case, you just get to see my mugshot. Many thanks for your time. There's more information available on the Foursys website, including information around our network security assessments, where we run this sort of assessment across people's networks, looking for these vulnerabilities and producing reports to ensure that you can protect your network from such attacks. Security awareness training, where you can sort of play around with this type of software in a safe environment, but also end user education, helping you protect your end users from these type of attacks as well. Thank you.